Yeah. Hi everyone. Thanks for watching this second video of the session continuation session. In the first session, we have learned the simple kernel modules, how to write, compile, load, and remove, and as well as to confirm the module is loaded or not. So those informations and how to compile. So what are the prerequisites to compile the kernel modules and loading stuffs. Okay. So coming to the next session, so what we are going to learn is, so we are going to utilize is the kernel data structure. So the basically kernel has many state, there are several state data structures. Uh, so how we are basically going to utilize those. So currently today we are going to look into the linked list support. Okay, so the linked list is we are going to see. Okay, so kernel structure. So this is the program from the similar to the first one. So we have added additional codes okay here to explore the data structure. So here is the header section first. Comes to the header section. So we have already seen the init section, kernels and modules for modulated functions and macros will be used here, and the list one. So the list is nothing but linked list here. We are going to utilize as the kernel linked list. So how do we utilize this? So for that we need a header file called nextlist.h file and the type file. So type file provides the list head structure. So I will come to the point later. Maybe you will be getting ready, and then GFP macros and slab functions are okay. These header files are mandatory to develop this kernel module. Okay, let's assume. So it should be a very careful module. So basically we are using the memory allocations and redefined and processing, right? So it should be in a proper way, and we should make sure this kernel modules are written properly. Okay, you can see the basic structure we have defined called the struct birthday. So which takes an parameter of which requires an three arguments, I mean three members, a day, month and year it takes, and then we are listing out one struct list head list. So this will be hold multiple list, like kind of assume that this is same similar to the linked list, right? It's a list head list. Okay, so this is the one structure. So this structure element, this structure will be available under the under the list functions. Here you can see the list and the type dot head. So the list struct list, it will be available in this, and list related linked list related functions are available at this list dot head. So these two header files are needed to perform the list related activities. Okay, fine. So now we need to list the head first. So list head, so we, let's say we are creating a list head first. So this creates a list head, we call it as birthday list. So what kind of list, linked list we are going to create is birthday list. Okay, just initializes the related initializes the birthday list related steps, the general list things. Okay, the list head has two members internally, which has one is previous and next, another one is next. Okay, so what we have expanded from the first kernel module to the second one is like in the same function. So we have added a structure and called name person and star person is equal to null, and we are allocating a memory for this. So dynamic memory allocations, so kernel memory allocations we are doing. So that's the reason k malloc. So the normal function has a malloc. The k indicates stands for the kernel, and we are giving the size of the structure, and we are saying GFP. GFP stands for that the kernel related memory allocation. So that indicates the kernel related memory allocations here. And then we are filling out some data over the 2 9 and 95 some days, month and year we are filling out. And what we do is like every time when we create a list, we are init the list. So we have initialized the list, and we are adding the list to the we are adding the list to the uh, we are adding that list to the main list. So main list is nothing but the birthday list. So the birthday list, what it does is it holds the list linked list basically. So we created a list, right? The list of this person of list, which is nothing but the person of list. We have created a variable called infrastructure birthday. So this person of list will be pointing to the list, birthday list. So what happens is keeps adding. If we are now here, now currently we have only one list, so we are adding a single list to the birthday list. Okay, and now I want to traverse the list. Okay, I want to see how many content, what are the contents are present. So then we have a function called list for each entry. So list for each entry, what it gives, it traverses the list from the beginning until the last. Okay, so we have to provide a pointer and the birthday list, so it gives the list and the list. We have to give it list. Okay, this is just mention the list we want to look upon. So what it does is this one, it just traverses each list from the birthday list, and it provides the address to the PTR. So that PTR we are printing here. You can see this, we are printing PTR day, month and year, and we are expecting is to print those data. Okay. Yeah, this is happens during the and the my driver model loads. So what we do here is what we learn from here. Basically we are allocating a memory for the structure, and we are filling out the data, and we are initializing the list head. Okay, so we created a list called birthday list. Let's kind of assume that kind of we have list to create a birthday list. So we'll keep adding the birthday persons on the list. So that's what we do here. So we have just initialize the list first. Okay, and then we keep adding. So list add daily, it just keeps add the list into the birthday list. Okay, and then we when put traverse the to traverse the list, we have a list for each entry. So we just keeps traversing the list in the birthday list bucket until the end of the list. Okay, and then if you want to so now the entry is fine, so we want to remove the module. So doing the removing of the module, so we have to safely delete the module. Okay, we have to delete the list, because since we have allocated the kernel memory space, if you are not deallocate, if we are not like free or remove the allocations. Okay, if you are not doing free, then what happens is the kernel leakage will happen, memory leakage is happening. Okay, so to avoid that, we have a function called simple list. So I mean simple exit function. During the exit of this module, I mean removal of the module, so we call the function called list for each entry. So list for each entry saved, so it just checks the previous and null is present or not properly from the bucket list. This is the list type. Okay, so what it does is inside this list, which we delete. Okay, this is if without problem, if this previous is present, so one list is present, then we get a pre-pointer to the list of that we are freeing out the memory, and we free the pointer basically. Okay, completely we are freeing out the pointer. So this way we are deleting the list from the bucket list, currently birthday list, and we are freeing out the memory allocated for the PTR. Similar, the PTR points to the address of the memory allocated here. Okay, and then after this is kind of for loop. Okay, in this function will run a number of lists we have. Currently we have only one list, so it runs only for one time. Similar to this also, this list for each entry is like this function is kind of for loop. It runs only multiple n number of lists which is present in the birthday list currently. Okay, so the similar procedure whatever we have executed here for a simple init and exit and modules, all those things. Okay, now if you want to change here, just for shake we are changing to kernel kernel data structure exploration. Okay, okay. So we have to make sure this make file present. Yeah, so here you can see now this -m for the we have added the 002 kernel stack. So to convert the generator dot object file from the file, and we when you do the make all, it's compile against this particular kernel version, and it provides the .ko file. Okay, so let's run the command make. It's compiled now. You can see this 002 kernel module.ko file is generated. Unless if you do, you can see. Okay, and then you clear this source control L, and if you want to know the model info, so model info of 002 underscore 002 underscore kernel struct dot ko file, you can see. So yeah, we have provided those informations and the code, right? So at the rise and description, so kernel data structure exploration is the description, and the kernel is this kernel module is compiled against the 5.4.150 generate. Okay, okay. So I just want to clear out, I think the message the message is cleared. Okay, fine. So now currently it doesn't have any message in the supply buffer. So what we are going to do is next we are going to run the kernel module now. So to do that, so to load the kernel module, we have to provide a permission, because we are going to load the into the kernel, right? So we need a permission, root permission, and then 0002 oh sorry I also have about execute 002 kernel struct.ko forgotten about this mod. Okay, so insmod is the user space command which loads the kernel module into the kernel. Okay, this one asking for the permission. Yeah, we loaded successfully without any error. So what we do is now we have to set the message. Yeah, you can see now simple kernel module entry function is loaded here. Is executed, and this print k function is executed, and you can see the date, month, and year is printed successfully. When this is happens only in entry function. So if you now when you clear, so while exit also, if you want to see the loaded module, so whether it is loaded properly and it's still running, so that you want to confirm, right? So you can use this command and list of modules. You can see the our module is loaded and it consumes this much size. Okay, now if you want to unload the module, you have to provide the rm mod, so remove module. So to provide the command, so then just tag, because this is available because this module is already in present. So you do this, then module is unloaded successfully without any error. So if you see this dmessage command, you can see the simple kernel module exit functions and clean up successfully. Yeah, so that's it for the session today, and I have been giving you one more assignment for you guys to explore. So what you need to do is like you can now currently we have used list, right? So you can see now to explore and gaining knowledge. So here you can see we have created only one list from this, like we have created a list of element, only one list. We have added a birthday list. Okay, only one list we have added here using this one. So you can write a program in such a way that we can create a file list. Okay, the file list can be added into this birthday list, and you can traverse the list and you can print the value of the file list with incremental value of those parameter numbers of each list. And while clearing out, you can delete all the file list and you can add a print of how many lists you are clearing out. Okay, so basically the assignment is you can create a file list. Okay, so that 5 birthday person list, five list, so needs to be added into the birthday list, and that needs to be traversed and prints the data with different values. And during the module removal, you can print how many lists you are deleted successfully. So that is an assignment. Yeah, upon the next video I will be showing you an assignment program. Okay, I will be giving a time for a few days, and post that I will explain the output of that. Okay, thanks for watching. If you learned something new from this video, please subscribe and like. Thank you.